Beirut, Chemistry Department, Chem 216, Analytical Chemistry. My name is Hassan Balbaki, and these are my colleagues Reem Romieh and Gael Khouri.
Today we will be working on an experiment that we did in our analytical chemistry lab, which is high pressure liquid chromatography. The purpose of our experiment is to determine the concentration of acetaminophen and caffeine in the solpadeine tablet and the concentration of aspirin in the aspirin tablet using HPLC. So this is the outline. At the beginning we will talk about the procedures and how did we prepare our samples. Then we will talk about the role of the HPLC in the separation technique. After that we will talk briefly about the machine's components. And finally, we will talk about the determination of the concentration of aspirin, acetaminophen, and caffeine after we obtain the data from the HPLC curves.
First of all, we will start by preparing 4 stock solutions, each containing one of the 4 active ingredients: caffeine, acetaminophen, aspirin, and phenacetin. During this experiment, we will be using phenacetin as an internal standard in order to correct the errors. Then, using micropipette, we will pipette from each of the stock solution to prepare 3 standard solutions containing all of the 4 active ingredients but at different concentration. Finally, we will prepare the solpadeine and aspirin solution by blending the tablets and mixing them with ethanol and water to the line mark.
This is the HPLC machine. First of all, we need to start it. We start it from bottom to top like that. It is composed of 4 modules. The first one, it's the power supply. The second module has 2 pumps. And the third one, it's the UV detector. And the fourth module, the screen, the display screen. And here, as you see, that's our mobile phase. It is composed of methanol and acetic acid, 60 to 40%. The pumps will press the mobile phase into the injector. So this is our injector. With the syringe, we inject our sample inside. The mobile phase will come and carry our sample through the loop. The loop will then transfer our sample through the guard. This guard serves as our last filter in order to remove every impurities in our sample. Then our sample will move through the column. The separation, all of the separation occurs inside. The components of our sample, which are aspirin, acetaminophen, and caffeine, will be separated inside. Because our stationary phase contains silica, which is extremely polar, and embedded with carbon 18, which is extremely unpolar. The highest, the compound which has the highest polarity will not come in contact with our stationary phase. Hence, it will be eluted first of all, and the most non-polar will come in contact with our stationary phase, and it will be eluted the last. Once the compounds are filtered, they will go out of our column and enter our UV detector. The UV detector will measure their absorbance because they are organic molecules.
So this step will be about explaining about the software techniques. After we turn on the computer, we click on the class VP, which is the software that we will need to work on. We click on instrument 1 and we should adjust the username and the password. We log in. Then, this screen should be applied with us. So we click on this first button to turn on the instrument. Then the second one is for turning on these 2 pumps. We should make sure that this pressure is around 200 bars. After this pressure will become about 200, we should click on this button to adjust the specific wavelength that we need to apply, which is 254 here. Then we click download. Okay. And apply. Then we close this window and we click on this for the run. We should name our sample, which is tablet 254 nanometers, and press start. So we click on this for the run. We should name our sample, which is tablet 254 nanometers. We click on start. We will wait for this instrument to write waiting for trigger to foot in order to inject our sample.
Now I want to demonstrate to you how do I do an injection. First of all, I will inject from my standard one. I will do an injection for two wavelengths, one at 254 and the other is at 225. First, before doing the injection, I need to rinse my syringe properly with methanol. Then I need to fill my syringe up to 40 microliter. Okay, that's 40 microliter. I want to make sure that there's no bubbles at all inside my syringe. Now I want to insert my syringe inside the injector. I hold my syringe with my left arm and I be very careful when I'm entering it. I press it inside, then hold the injector rotated to the right in the inject position. Then I remove my syringe. Then I return it back to the load position. After finishing injection, a couple of signals will appear on my screen. You can see here the peaks. It will take 8 minutes until the first injection will finish. After 8 minutes, I need to start my second injection, which is also standard one, but at another wavelength, which is at 225 nanometers. I will do the same thing for standard 2 and 3, and for my tablet sample. Here, I want to emphasize something, that we are using here two wavelengths because the maximum absorbance of acetaminophen and caffeine is at 254, and the maximum absorbance of aspirin is at 225. After waiting for 8 minutes, we can see that we obtained such a graph. There are 4 peaks. We need to do an integration for each one in order to obtain the area of the peak. You can notice here that the third peak, which is for the aspirin, is not very clear because the absorbance is at 254 nanometers. If we opened the 225 standard one at 225 nanometer, we can see that the fourth peak is much more clearer, because the maximum absorbance of aspirin is at 225. So by doing the same thing for standard 1, standard 2, and the standard 3, we can build a calibration curve for each of our compounds. After building our calibration curve by plotting the peak areas over the concentration, we get 3 calibration curves for every active ingredient. Now we need to open, we need to see the signal of our tablet. We need to integrate for every peak area. So, for example, the first peak is for acetaminophen. We take the peak area and we plug it in the equation of the calibration curve of the acetaminophen. By this, we can get the concentration of the acetaminophen. We will do the same thing for the aspirin and the caffeine.
Based on the result we got from the HPLC, we conclude that they are very similar to the theoretical one written on the boxes. Hence, HPLC is a very good method and experiment in order to get the concentration of some compounds.
Bye.
Thank you. Bye.